Let's create a new project, where the topological processor will be used to colorize energized lines. First, we add component called spin_topology, which contains all the necessary functionalities, like one. Templates representing the bays with their structures. 2. Scripts that run the topological processor. 3. Symbol library with all symbols used to represent the bays in a single line diagram. After the addition of the component, we will customize the application, which will contain 3 interconnected regionals, Sepitan 1, 2 and 3, each of them with many bays. Once we have created the regionals, with all their bays, we will create the screen with a single line diagram. Concluding the customization, we will create the adjacency matrix that establishes the bays' sources of energy, and the bays that are fed by them, depending on the state of their circuit breakers. After creating the application, we will execute it and, as shown, whenever we change the position of the switches, the colors of the bars and feeders change, depending on whether or not they are energized. The topological processor is generic, and supports any type of bay and single-line diagram. Let us now create the application. Initially, we will create the bay objects associated to each regional, first the bays of Sepitan 1, then Sepitan 2 and finally Sepitan 3. To create a bay, we type its name, select the associated template, type its level, and its category. Note that in the associated template, there is all the information necessary for the topological processor color the bay. After creating all the object bays, let us create a screen, and put them on it. The lean automation methodology transforms the definition of the bay object into its drawing, according to the symbol library. First we will create the bays associated to the regional Sepitan 1. After that, we will adjust the position of the bays in the draw, and repeat the procedures for the next regionals. Now we create and adjust the second regional. Finally, we create the third regional, and the single line diagram is ready. To create the matrix, we initially insert the bays, that are energy sources, which are the three transformer bays, and after the other bays organized by regional. The adjacency matrix is generated and marked with an X connecting bays. In short, to generate an application with topological processor, using lean automation, just add the spin topology component, create the application bays, associating them to the templates available in the component, using copy and paste, create the application screens with their single lines diagrams. Finish the screens, we create the adjacency matrix running the topology generator extension. As shown in other lean automation videos, run the deploy extension that generates the tables of alarms, historical data, and points. That is all, the application is ready to be tested.